All right, let's dive into the world of software design patterns.
Yeah.
Today, we're going to tackle the prototype pattern, um, one of those clever solutions developers came up with to solve a pretty common problem.
Mhm.
You sent over some really great resources on it, so we're going to break it all down.
It's like having a secret weapon in your coding toolkit.
Oh, I like that.
The prototype pattern, it helps you copy objects efficiently, especially when you're dealing with complex systems where traditional copying just wouldn't cut it.
So before we even get to the how, I'm curious about the why.
Uh.
When would I actually need this prototype thing in my code?
Hmm.
Paint me a picture.
Okay. Imagine you're building a game
Okay.
and you need to create a bunch of different enemies, each with slight variations.
Yeah.
Copying each enemy object from scratch, it would be a nightmare. Or think about a design app where users are constantly duplicating elements.
Right.
Prototype, it helps you avoid writing a ton of repetitive code for these scenarios.
Okay, so that makes sense. But why can't we just use regular old copying? What makes these scenarios so tricky?
So often you don't want to be tied to the specific classes of the objects that you're copying.
Right.
What if you need to create a copy without knowing all the details of the original object structure?
So it's like making a blueprint
Yeah.
that can be used to create variations without knowing the exact recipe of the original.
Exact.
Okay.
Plus, think about private fields within a class. Traditional copying mechanisms, they might not be able to access those directly.
That's where prototype swoops in to save the day.
Right.
Right. I think the refactoring guru article mentioned something about it being like cell division.
Yeah.
I love that analogy.
It's a perfect way to visualize it.
Yeah.
In essence, prototype, it lets an object clone itself. Think about how cells divide. They create exact replicas without needing to know the entire blueprint of the organism.
So instead of relying on external code to make the copy, each object has the power to reproduce itself.
Yes.
Clever.
Exactly. And this self-replication idea is implemented through an interface
Okay.
with a clone method.
Gotcha.
And each object then defines how to copy itself within that method.
So it's not like a one-size-fits-all solution.
Right.
Each object gets to decide how to make a copy of itself.
Right.
That's pretty elegant. I can already see how this would make the code so much more flexible.
You got it.
Yeah.
The client code that needs a copy doesn't have to worry about the specific details of the object's class. It just calls the clone method, bam, a copy is born.
Right. Walk me through an example of how this works in practice.
Yeah.
Refactoring Guru had that geometric shapes example.
Right.
Can we use that?
Absolutely. Imagine you're creating a design tool,
Okay.
and you need to let users duplicate shapes, squares, circles, triangles, you name it.
Yeah.
Without prototype, you might end up writing separate copying logic
Oh, gosh.
for each shape.
Which would be a total pain, especially if you add new shapes later on.
Right.
So with prototype, each shape class would have its own clone method.
Precisely. The clone method for a circle would create a new circle object and copy all the relevant data, the radius, color, position, and so on. Same goes for the square, triangle, any other shape you can dream up.
So it's not just creating a shallow copy.
Right.
It's actually making a brand new object with all the same properties.
Exactly. And that distinction is crucial. You're not just pointing to the same object in memory. You're getting a fresh, independent copy.
This is all making sense so far, but you mentioned earlier that prototype isn't always like a perfect solution. The transcript we got talked about circular references being a potential issue. Can you elaborate on that?
Sure. A circular reference, it occurs when an object refers back to itself, directly or indirectly through a chain of references. Imagine object A has a reference to object B, and object B has a reference back to object A.
Like a closed loop.
Yeah.
You can see how that would mess things up when you're trying to make a clean copy.
You're right. When you try to clone an object with a circular reference, you might end up in an infinite loop.
Oh, no.
Where the cloning process, it never stops because it keeps encountering the same reference over and over.
So it's not that prototype can't handle it at all.
Right.
But it requires extra care and potentially some workarounds.
Exactly. You might need to implement custom logic to handle these circular references properly during the cloning process.
Okay, good to know. Now, besides the geometric shapes example, are there any other real-world scenarios where prototype really shines?
Absolutely. Think about scenarios where you need to create a complex object based on an existing template, but you also need the flexibility to customize certain aspects of the copy.
That sounds like a pretty common need in software development.
It definitely is. And Prototype, it provides a powerful mechanism for achieving this type of object creation.
Now, we also got a YouTube link from Derek Ben-Ass. He uses animal cloning as an example. I love it.
Yeah.
It's cool how he brings it back to the real world.
Right. His example with the sheep and animal classes, it highlights how Prototype works within a class hierarchy. And he brings up an interesting point with the clonable interface in Java.
Oh, yeah, the transcript mentioned that. What exactly does clonable do? Is it like a permission slip for cloning?
You could say that. Marking a class as clonable, it essentially signals that it's safe to create copies of its instances using the clone method. It's a way of ensuring that the cloning process, it won't lead to, like, unexpected issues.
So it's a way for developers to, like, communicate their intentions about how a class should be used.
Precisely. It's a way to add a layer of safety and clarity to the cloning process.
This is all making a lot more sense now, but I'm still curious about that clone factory thing.
Yeah.
That Derek Ben-Ass mentions in his video.
Right.
Is that part of the core prototype pattern?
It's not strictly part of the, like, fundamental pattern, but it's a common and useful addition. Think of it like a cloning control center.
Okay.
It manages the creation of clones and keeps things organized.
So it's not essential, but it adds a layer of organization
Right.
and maybe even like some extra functionality.
You got it.
Yeah.
A clone factory can be a powerful tool, especially when you're dealing with a large number of different prototype objects.
So instead of having like cloning logic scattered all over your code, you can just centralize it within the factory.
Yeah.
That sounds pretty efficient.
Exactly.
Yeah.
It helps keep your code clean, maintainable, and easy to extend.
All right, now I want to shift gears a bit. We're going to talk about the benefits of using Prototype.
Okay.
We've touched on some already, but I want to make sure our listener really understands like why this pattern is so valuable.
Sounds good to me. We can start by highlighting how Prototype promotes code reuse and reduces redundancy.
Because you're not rewriting the same copying logic over and over again, right?
Exactly.
You're leveraging the power of inheritance and the clone method to handle the heavy lifting.
Exactly. And this, it leads to more maintainable code. If you need to make changes to the way a particular object is cloned, you only need to update the clone method in that object's class.
Which is way better than having to like hunt down and modify multiple chunks of code throughout your project.
Absolutely. And beyond that, Prototype enhances flexibility by decoupling the client code from concrete classes.
Right.
Remember that game example?
Yeah.
If you add a new enemy type later on, you don't have to change the core game logic that handles enemy creation.
It's all about adaptability and making sure your code can like evolve easily.
You got it. Prototype empowers you to create complex systems that are easy to maintain, extend, and modify.
This is all great stuff, but I don't want our listener to think that Prototype is like a magical solution for every scenario. It's important to be aware of the trade-offs, right?
Of course. Like any design pattern, Prototype has its strengths and weaknesses. We've already talked about the potential issues with circular references.
Right. And there's also the fact that implementing the clone method correctly can sometimes be tricky.
Yeah.
It's not always as simple as just copying fields from one object to another.
You're absolutely right. There might be cases where you need to implement deep copying to ensure that all nested objects are properly duplicated.
And if you're not careful, you could end up with unintended shared references between the original object and its clone, which could lead to all sorts of nasty bugs.
Exactly. It's important to understand the nuances of object copying and to choose the right approach based on the specific needs of your project.
This has been a really insightful exploration of the prototype pattern so far. I'm already starting to see how it can be like a powerful tool in my own coding arsenal, but I'm sure our listener is eager to see some actual code examples to really like solidify these concepts.
You read my mind. In the next part of our deep dive, we'll take a closer look at some real-world code examples, including Derek Ben-Ass's animal cloning code and the geometric shapes example from Refactoring Guru.
Awesome. I can't wait to like break those down and see how all these pieces fit together in practice.
Yeah.
All right, so stay tuned for part 2 of our deep dive into the prototype pattern.
We'll be right back. All right, let's dive into some code and actually see the prototype pattern in action.
Okay.
We'll start with Derek Ben-Ass's animal cloning example from his YouTube video.
Okay.
He uses a sheep class as a concrete prototype.
Ooh, sheep cloning. It doesn't get much more real world than that.
Right.
I remember in his video, he had this animal class as well, right?
Exactly. The animal class, It acts as a sort of blueprint or template for different animal types.
Okay.
It has, like, basic attributes like name and sound, which are inherited by the sheep class.
So the sheep class is like a specialized version of the animal class,
Yeah.
inheriting those basic traits. So does that mean if we clone a sheep, we'd also be cloning like its animal characteristics?
You got it. And that's where the power of inheritance comes into play.
Yeah.
The sheep class, it overrides the clone method from the animal class to define how to create a copy of itself.
Okay, so walk me through that clone method in the sheep class. Like what's actually happening? What's happening under the hood?
So in Bonus's example, the clone method in the sheep class, it first creates a new sheep object. Then it copies over the relevant attributes from the original sheep, like its name and sound.
So it's like taking like a blank slate of a sheep
Yeah.
and then filling in all the unique details from the original sheep to create the replica.
That's a great way to put it.
Yeah.
The key takeaway here is that the clone method is responsible for creating a new independent object with the same properties as the original.
And to ensure that the cloning process like works smoothly, Bonus uses the clonable interface, right?
Exactly. Remember we talked about that earlier.
Yeah.
By implementing the clonable interface in the animal and sheep classes, Bonus is essentially marking them as safe for cloning.
Yeah,
It's like giving them a stamp of approval for the cloning process.
I like that. And he also introduces this clone factory concept to manage the cloning process, right? Sort of like a cloning control center.
You nailed it. The clone factory, it acts as a central hub for creating clones of different animal types.
Okay.
It has a method that takes an animal type as input and returns a clone of that animal.
So instead of having like cloning logic scattered all over the place, we can just call this clone factory whenever we need a copy.
Precisely. It keeps the cloning process organized and makes the code more maintainable.
All right, so that's Bana's animal cloning example. Now let's switch gears to the geometric shapes example from the Refactoring Guru article.
Yeah.
They use this scenario to show how Prototype works within a class hierarchy.
Yes, this example is a great way to visualize how Prototype can be used to manage different types of objects that share a common base class.
So we have a bunch of shapes.
Right.
Circles, squares, triangles.
What?
And they all inherit from a base shape class.
Right. Exactly. And each of these concrete shape classes implements the clone method to define how to create a copy of itself.
So the circle class's clone method would know how to make a new circle object.
Right.
The square class would know how to make a square object, and so on.
You got it. And because they all inherit from the same base shape class, the client code can treat them all as generic shapes without needing to worry about their specific types.
That's where the flexibility and adaptability of Prototype really shines. You can add new shapes to the system without breaking existing code.
Exactly. As long as the new shape class implements the clone method properly, the rest of the system can work with it seamlessly.
This is really cool stuff. It's amazing how a simple concept like cloning can have such a profound impact on code organization and flexibility.
I agree. And the best part is that Prototype is a relatively straightforward pattern to implement once you understand the core concepts.
I'm feeling a lot more confident about using Prototype in my own projects now. But before we wrap up, I want to bring it back to our listener and make sure they understand why they should care about this pattern.
That's a great idea. Let's highlight those key takeaways one more time.
So, listener, if you're dealing with scenarios where you need to create multiple copies of objects, especially if those objects have complex structures or belong to a class hierarchy, Prototype can be a lifesaver.
It can save you from writing tons of repetitive code.
Yeah.
Make your code more adaptable to changes and improve the overall maintainability of your projects.
And even though it's not a magic bullet for every situation, understanding the Prototype pattern adds a valuable tool to your coding arsenal.
It expands your thinking about object creation and gives you a powerful way to manage complexity in your software designs.
All right, stay tuned for part 3 of our deep dive into the Prototype pattern. Before we let you go, I want to leave you with something to chew on.
Okay.
We've talked about Prototype in the specific examples, like game characters, geometric shapes. But what other areas of software development could benefit from this pattern?
That's a great question. Prototype's strength lies in its flexibility. So think about any scenario where you're creating objects based on templates or configurations.
So instead of hard-coding the creation of every single object,
Yeah.
you could use Prototype to, like, streamline the process and make it more adaptable.
Precisely. Imagine you're building a system for managing user profiles.
Okay.
You could have a base user profile class,
Yeah.
and then use Prototype to create different types of profiles,
Okay.
like basic, premium, admin, so on, without writing, separate creation logic for each one.
Or what about like a content management system?
Right.
Where you need to create various types of content, articles, blog posts, videos.
Mhm.
Prototype could be a game changer there.
You're catching on quickly.
Yeah.
The key is to recognize those patterns of object creation in your projects and see if Prototype can, simplify and enhance your design.
I'm uh, uh, I'm already starting to see Prototype everywhere now. It's like I've unlocked like a secret level in my coding skills.
That's the beauty of learning design patterns. They change the way you approach problems.
Yeah.
And open up new possibilities for creating, elegant and efficient solutions.
Well, this has been an incredibly insightful journey into the world of the prototype design pattern. Uh, I feel like I've gained like a whole new level of understanding, and I hope our listener feels the same way.
I'm confident they do.
Yeah.
And remember, the best way to solidify this knowledge is to put it into practice.
Yeah.
Experiment with Prototype in your own projects, see how it fits into your workflow, and, don't be afraid to get creative with it.
Exactly. The more you use it, the more you'll discover its power and versatility.
And if you stumble upon any clever or unexpected applications of Prototype, we'd love to hear about them.
Oh, yeah.
Feel free to share your experiences on our social media channels.
We're always thrilled to hear from our listeners and learn from their insights.
Until next time, happy coding.
Yeah.
And may your clones be ever efficient and elegant.
Thanks for joining us on this deep dive. We'll catch you on the next episode.